area of regular polygons. So before we actually jump in and start solving polygons, the area of polygons, we need to actually do some reviewing of some skills that are going to be handy for us. So one of the skills we need is to be able to figure out the angle measures of these particular figures that we're dealing with, whether it's pentagon, hexagon, octagon, whatever. So let's first talk about the parts, okay? So if you think about this polygon as being inscribed inside of a circle, so this this particular figure that we have has to be inside the circle. So we're going to put this point right here, and we're going to call that the center, okay? So we know that that's the center, and I'm going to just draw a solid line to the center and then just a dashed line over here because I need to call that segment something after. And we're going to put our dashed lines to each corner of our figure, except this one over here I want solid. So put your dashed lines in. So we have our center point, right? So center, just as though it's the center of the circle, it's still the center of the polygon. So you have to sort of imagine that there's a circle around that figure and that you have your center point. This dark line over here, we're going to put an R on this. We're going to call that a radius. So a radius measures the distance from the center of a circle to its outside edge. And you can see that this point is in fact on the outside edge of the circle. So that segment between the center of that figure to one of its corner points is equivalent to the distance from the center of the circle to the outside edge of the circle. Okay, so that's why we call it a radius. It's exactly the same measurement. Radius. If you have more than one radius, though, it's called a radii, or they are called radii, with two i's. Radii, and that's equal to more than one. More than one radius. So we want to make sure we sound all fancy when we talk and say these words properly, and that we're all talking about the same things. So when you have more than one radius, you have a set of radii, and this particular figure has 1, 2, 3, 4, 5, 6 radii in this figure. Okay? So a six-sided figure has 6 radii. Okay? It also has 6 triangles that have been broken up by those radii. So 1 triangle, 2, 3, 4, 5, 6. Six-sided figure, 6 triangles, 6 radii. Okay? Then we have one more thing we have to talk about, and it's this segment. And it's different than a radii because it goes from the center of the circle directly down to one of the sides. The shortest distance between the center and one of the sides forms a right angle, just like an altitude, except we don't call it an altitude because we like to make things confusing in math, and why would we want to use the same word to mean exactly the same segment? We call this instead an apothem. Okay? And it's spoken like apothem. Okay? The apothem. Very similar to the altitude of that triangle. It is the apothem of the hexagon, the altitude of the triangle. Now, those are the parts that we need to know in order to find the area. Okay? So let's talk a little bit about finding the angle measures, though, because this part's really important. So find angle measures. The figure at the right is a regular pentagon with radii and an apothem drawn. Find the measure of each numbered angle. So here you go. Let's number the angles. I want you to put angle number 1 in here. And I want you to call this angle right here number 2. And then this one down here number 3. Okay? So angle 1 in red. Let's concentrate on angle 1 in red right now. We call that a central angle. It's a central angle because it is formed at the center of the circle, and there is the same number of central angles as there are sides. Okay? So if we look at this, we have one central angle, 2, 3, 4, and then this is an entire central angle. Remember, it's just broken up by the apothem. So that part's hard to visualize for students sometimes. So if you look at the sides, one triangle, 2, 3, 4, 5. So we actually have 1, 2, 3, 4, 5 central angles. If I drew marks on those, 1, 2, 3, 4, and the one I drew earlier, 5. Okay, so 5 central angles. So I'm going to get rid of these other marks for now. Angle number 1 is this central angle. Okay? How many degrees would that central angle be? So here's the trick, or how we would do this, right? So an entire circle, remember this is like embedded inside of a circle, is 360 degrees, right? So we're going to take 360 degrees and we're going to divide it. The question is, how much do we have to divide it by to figure out what that angle number 1 would be equal to? So how many of them are there? We just counted 1, 2, 3, 4, 5. So the same number of sides. So we're going to divide by 5, and we find out that angle number 1 is 72 degrees. So divide 360 by the number of sides. That's how you get the central angle. Divide 360 by the number of sides. Okay? So angle number 1. Anytime you need a central angle, divide by the number of sides. All right, let's talk about number 2. So get rid of some of this stuff around the outside. If I look at angle number 2, and I just erased 3. If I look at angle number 2, I'm going to realize that this is a central angle, and I'm really just looking for this part of it. So really, how much of that central angle do I want, right? So angle 2 represents half of angle number 1. So what I did is I drew the apothem in here, and now I'm asking you to find this section, right? I only want you to find part of it. So here's what we do to find angle number 2. It is 1/2 of angle 1. Angle number 2 is 1/2 of angle 1. So if angle 1 is 72, we're going to divide that by 2, or take half of it, and we're going to get 36 degrees for angle number 2. So anytime you need the angle that is sort of on either side of the altitude, so in our first example, this angle or this angle, those are half of the actual central angle. So you find the central angle and then you divide it by 2. That's how you get that angle. Okay? Angle number 3, if you look real careful, is part of this triangle, right? We just found angle number 2 to be 36 degrees. And we know that this is a 90-degree angle because it's bordering a 90-degree angle. And now I'm looking for angle number 3. So what do I know about 3 angles of a triangle? 3 angles of a triangle equal 180 degrees. So I'm going to do angle number 2 plus angle number 3 plus that 90-degree angle that I have, and that should equal 180. So plug in what you know. I know that angle number 2 is 36. I just found that over here in the second question. Plus angle 3 plus 90 equals 180. You can combine your like terms. So 90 plus 36 is going to be 126 plus angle 3 equals 180. Subtract the 126 from both sides, and angle 3 is going to equal 54 degrees. So you find the third angle by adding the angles together that you know and subtracting them from 180. That skill is going to be important, being able to find your angle measures. So let's try that one more time. Let me scroll the page up, and we're going to find angle measures one more time. We really have to be quite good at this. So this time I'm giving you an octagon, and I'm going to ask you to find the angle measures. So here's what I want you to do. Go ahead and put in all of your segments to your corners. right? And they're all going to cross at the center. So there's my center, okay? And I want you to label them like this. I want angle number 1. We're going to draw in an altitude right here. And I want you to call that angle number 2. And then, excuse me. Excuse me. And then angle number 3 right here in the corner. All right, so let's go through that same process we just did a minute ago. So I need angle number 1. So I want this angle. So I have to figure out how many there are. 1, 2, 3, 4, 5, 6, 7, 8. So I have to do 360 divided by 8, and that's going to give me 45 degrees. Okay, so this is the number of sides. That's how I found that. So angle number 1, 45 degrees. Perfect. All right. So if I look at that, if I take this triangle and I drop it down, I'm telling you that this angle up here is 45 degrees, the whole thing, okay? But then I dropped this altitude in here, and I'm telling you now that that's angle number 2, and this one's angle number 3. So now I need angle number 2, which is going to be 1/2. So the measure of angle 2 equals 1/2 the measure of angle 1. So I need 1/2 of 45 degrees. And that's going to give me the measure of angle 2. Half of 45 is 22.5 degrees. So angle 2 is 22.5 degrees. Okay? Angle 3. Again, so I broke down my big triangle, my one of my central triangles. I dropped that down. Now I'm going to drop this guy down. I just want this piece. So this is 22.5. I know that this is 90, and now I need angle 3. What in the world is angle 3 going to be? Probably shouldn't have written that quite so close. Let me move that over. All right, so let's find angle 3. So again, those 3 angles have to add up to 180. So I have angle 3 plus 90 plus 22.5 equals 180. Combine your like terms. Angle 3 plus 112.5 equals 180. And then I'm going to subtract the 112.5. And angle 3 equals 67.5. So I'm able to find that third angle. Okay? So before you move on and start working on actually finding the area of a regular polygon, if you still feel like you need more practice finding angle measures, please ask. We'll throw some items down on a paper for you so you can take some time and practice this skill before you move on.